Most of us here in Helena don't really think about where our water comes from. We take it for granted that when we turn on the faucet, there's always clean water there for us to use. Let's take a closer look at where that water comes from and how they clean it. Here we're going to be taking a look at the Tenmile water treatment plant. This is the primary source of water for the city of Helena. The city of Helena Tenmile water treatment plant. And the reason it's called Tenmile is because all of the water collected that comes into this facility is from the Tenmile watershed. Just to give you a few numbers, the average million gallons per day that this plant usually treats is 5.9 million gallons a day. That's the average for the whole year. There's a high in the summertime of 8 million gallons a day and a low in the winter of 3.5 million gallons a day. Now, 8 million gallons a day is not enough for the entire city in the summer, so extra water is taken from the Missouri River plant. The reason we do not use the Missouri River plant for the majority of the year is gravity. All of the water from the Tenmile watershed flows downhill to Helena. This saves about 80% for the cost to produce clean water for the city of Helena. It costs 80% more to produce water at the Missouri River plant due to chemicals used and utilities, mainly electricity to pump that water uphill. So gravity is a big help for the water here at the Tenmile plant flowing downhill to Helena. The cost for water for a flat rate resident in the city of Helena, it costs about 4 cents for 10 gallons of water. Think about that compared to bottled water from the store. And the fact that most bottled water from the store is water that originally came from a city plant like Tenmile. That's quite a savings for 4 cents for 10 gallons of water. Here's another view of the Tenmile plant. Again, this plant is capable of producing almost 8 million gallons per day. Like I said, in the summertime, Helena uses more than that, so we supplement from the Missouri River plant for a high of a little over 15 million gallons per day that the city of Helena uses. Now, the city of Helena is hydraulically locked at 20 million gallons per day. What that means is if the demand exceeds 20 million gallons, the Missouri River plant and the Tenmile plant will no longer be sufficient to provide water for the city of Helena. An alternate will be needed, and most likely, if Helena ever does exceed the demand of 20 million gallons per day, it will be from deep water, deep in the aquifer, groundwater. Here we're looking at a map of the Tenmile watershed, and you can see from the map that two of the primary sources are Chessman Reservoir, which is a man-made reservoir that was constructed in 1894, and Scott Reservoir. Those are just two of the sources from the Tenmile watershed. We're going to take a closer look at some of the tributaries that help produce water for the Tenmile facility. Now, this facility is cleaning water for upwards of 35,000 people. Now that's more than what live in Helena, but there is a daily influx of people that are from out of town that come to Helena for work or school or shopping or just visiting. They estimate 35,000 people on a daily basis are using water from the Tenmile facility. Here we're looking at one of two wells that are used to supplement the Tenmile water treatment plant in the summertime when the creek is very low. They'll pump water from the ground. There's the pump house. So two wells using groundwater to supplement the water at Tenmile treatment. Here we're looking at Walker Creek, a tributary to Tenmile, where water is collected for the Tenmile treatment plant. Walker. Here we have Moose Creek, another tributary to Tenmile Creek, where water is collected and sent to the Tenmile plant. Here in this silver pipe is water collected from Minnehaha Creek, another tributary that helps add water to the Tenmile plant, collecting it from several tributaries as well as Tenmile Creek. Minnehaha. Here we're looking at the Tenmile head gate, where they'll collect the water. It'll go into the main line that takes the water to the Tenmile water treatment plant. Tenmile head gate. Here we have Beaver Creek, another tributary to Tenmile, with a head gate where water is collected and sent to the Tenmile water treatment plant. So water is collected from Beaver Creek, Minnehaha Creek, Moose Creek, Walker Creek, and Tenmile Creek, as well as Scott and Chessman reservoirs, and supplemented by groundwater wells in the summer. We're about to start our tour, but first a couple of vocabulary words that I'll use throughout the tour. Influent is the untreated water coming into the plant. Effluent is clean water leaving. So it's been treated and cleaned, and when it leaves the plant, it's known as effluent. Flock is a term used when they add chemicals to create flock. It is clumps of dirt that end up sticking together to make the clumps large enough to be filtered out. Those clumps of dirt are also known as turbidity, dirt in the water. So when they add certain chemicals to the water, the turbidity sticks together to form flock, larger clumps of dirt which are easier to filter out. Here we are in the headworks. This is where the influent first enters the plant. Sounds like a waterfall. The water flows over the screen, and the screen filters out pine needles, leaves, sticks, fish, any of the large solids that are in the water get filtered out by the screen. Influent coming into the headworks. After the water enters the headworks, it comes into this green pipe. All of the piping here at the Tenmile water treatment plant are color coded. The water is in this great big green pipe. The different chemicals that are used are also in color coded pipes, which we will get to when we visit the chemical room. After the water flows into the headworks and exits in the green pipe, it comes up underneath the blue tanks known as contact adsorption clarifiers. So here we have our 4 green pipes bringing the water into and up through a layer of beads. The beads will filter out the turbidity and floc. Over time, those beads need to be cleaned by a process known as backwashing. So the water travels up through the beads, over the top into the trough, and onto the filter bed. Here we're looking at the contact adsorption clarifiers, a model so that we can see what is inside of the blue tanks. Now the tube is kind of hazy, but you can see we have water and then a layer of plastic beads that are suspended and water. And here is a look at the plastic beads. The beads are what filter the floc and turbidity out of the water. Now over time, the beads will get clogged up and they need to be rinsed. It's a process called backwashing. They reverse the flow of water and introduce air and bubbles that cleans the turbidity and floc out of the beads and goes out into the settling lagoon. Here we're looking at the filter beds. There are 4, and underneath the water are the layers of sand and gravel and rock. They want to keep the right amount of water in these tanks. If you have too much water, it creates pressure and forces the water through the filter bed too quickly. If you do not have enough water, it takes too long for the water to filter down through. We'll walk down here and take a look. You look on the wall, looks like they keep about 5 feet of water in the filter bed. Just the right amount of time for that water to slowly filter down through those layers and get finished being cleaned and filtered and polished. Over time, the filter beds will also get clogged with dirt, so they too need to be backwashed. Here we're looking at a model that represents the filter beds. Layer of anthracite coal, silica sand, high density sand, high density gravel, and silica gravel. Kind of copied Mother Nature's aquifer as far as how to filter and clean the water. Looking through this window, this used to be the chlorine room. A few years ago, they still used chlorine gas to chlorinate the water. Chlorine gas is very, very deadly, so it had to be contained in this room. They have switched and no longer use chlorine gas. So here we are in the chemical room. As you can see, the color-coded pipes. The first one here, the red pipes, is for the alum. Alum is what is used to add to the water. that makes the turbidity clump together and form flock. Here, the caustic soda, that's similar to drain cleaner. That is used for adjusting the pH of the water. The water they bring into the plant is about 6.8, 6.9. They actually adjust it up to about 7.4. The green pipes, orthophosphate. This is for coating of the pipes, and it helps prevent corrosion in the pipes. So I said they switched from chlorine gas to chlorine liquid, which is a lot safer. But anytime you're dealing with chemicals, you got to have safety equipment. So behind me here, we have an eye wash station and a chemical shower, very similar to what you would see in your science lab. Let's see if they work. Yep, shower works. So does the eye wash. Always have to have the safety equipment. Well, at the Tenmile water treatment plant, underneath this cover is 6 million gallons of clean water ready to go to town. Been filtered through the headworks. Pine needles and leaves were removed. The CACs, where the beads filtered out the flock, and then eventually the filter bed, the different layers of sand and gravel and rock that cleaned and filtered and polished the water, and then a little bit of chlorine added to make sure that there's nothing living in the water that's being sent to town. 6 million gallons of clean water under this cover. The reason for the cover, keep the water clean. Taking a look here at the storage reservoirs used in Helena. Woolston Reservoir, Hale Reservoir, Upper Hale, Malbin, and Winnie. These all supplement the clear well for a total of 15 million gallons of clean water available for the city of Helena to use. This provides water pressure and also provides the fire department with lots of water in case of emergency. We also have the Missouri River Treatment Plant that can supplement the Tenmile plant in the summertime. The demand for water goes from about 3.5 million gallons per day in the winter upwards of 15 million gallons per day in the summer. The Tenmile plant is only capable of producing about 8 million gallons per day. So the Missouri River is used, that water is cleaned the same way the water here at Tenmile is cleaned. The reason we do not like to use the Missouri plant more often is they have to pump that water uphill, and it's very expensive to pump that water. Tenmile is gravity fed to the entire city of Helena. Water flows downhill, don't have to pay to move it. Behind me here we have the settling lagoons. This is where the backwash water comes from the CACs and the filter beds. You can imagine how dirty that water gets after cleaning of the beads and the cleaning of the sand and gravel in the filter beds. that dirty water comes out here to these settling lagoons where all that dirt settles to the bottom, and the water then is fairly clean, and the neighboring rancher uses it as irrigation. Here we have Ben Rigby, he's the superintendent of the plant, sitting at the control board here. This plant is fully automated, which means it will operate and continue to clean water even when the guys get to go home. Here we're taking a look at the lab where they run all their tests to make sure that they are cleaning the water properly. Now, we just saw the control room. The computer can monitor and control almost anything that goes on here at the plant. But how do they know if the computer says that the chlorine levels are 0.83 parts per million? How do we know it's correct? Well, the guys would get a sample and test it here in the lab, and they should match. They are regulated by the EPA, the Environmental Protection Agency. They basically set the rules. That's the federal government. And the DEQ, Department of Environmental Quality, is the state, and they enforce the rules. The water has to be cleaned to a certain level or they are breaking the law. So here in the lab, they have to test for certain things before the water can be called finished and cleaned. They test for color, clearness, odor, pH, and chlorine residual. They are typically adding about 1 part per million of chlorine, so that's 1 gallon of chlorine for every million gallons of water. And chlorine will evaporate over time. A lot of people don't like the taste of the chlorine in the water. You can simply fill up a pitcher and put it in the fridge overnight. That chlorine will be gone by morning. That chlorine residual must stay above 0.3 parts per million by the time it reaches the furthest faucet in Helena. Now here in Montana, we're very lucky that we have clean water to use as our drinking water. What we're looking at here is a sample of influent on the left, raw untreated water, and effluent on the right. That's cleaned water leaving the plant. You probably couldn't tell much difference if we didn't have the white sheet behind them, but you can see there's a little bit of color. A little bit of color. So basically what they're removing from the water in this whole treatment process is dirt and germs. Viruses, bacteria, living organisms that could make you sick, and the turbidity from the water. Certain times of year, it's a lot harder to clean. Spring runoff, very, very turbid water from the spring runoff and the snow melt. It gets a lot dirtier, a lot harder for them to clean. The fall, they get a lot of leaves and pine needles washing down. That is also need to be removed from the water. Influent versus effluent. Hopefully now you have a better understanding of where we get our water in Helena and how it's cleaned. Now, if this is something that interests you, that's a good thing, because there's always jobs available in water treatment. Almost every community is going to have drinking water treatment and wastewater treatment. Very good jobs. So hopefully some of you will go on and pursue this career.